between empirical and theoretical? Yeah, what is it?
Isn't empirical like what actually happens from is the probability derived from the experiment and then what actually happens, and theoretical is what you expect to happen.
Correct. Oh, I froze it? Uh-oh. Sorry, there you go. Sorry. I was just pointing, not writing, but yeah. So, Karima says that empirical is based on like actually doing something, and then it's kind of like figuring out the probability after the fact. And theoretical is just based on what should happen, right? So like the odds, theoretical odds of, or the theoretical probability of tossing a coin and getting a heads is 1/2, right? But the empirical, well, if you ran 10 experiments, who knows what it would be? It might be 6 out of 10 or whatever. Okay. What about mutually exclusive? Oh, does anybody know that? What do you think, April?
It's something that cannot happen at the same time.
So 2 things that cannot happen at the same time. Mutually exclusive. Right. Like fun in English class. It's not true? Actually, I really liked English class. Oh, it is truth. Oh. All right. Hey, how about somebody gives me an example of something that is mutually exclusive? How about Sophia gives me an example of 2 things that would be mutually exclusive? No, they cannot.
Oh, they cannot.
Yeah, mutually exclusive means they cannot happen at the same time. Exclusive, yeah, anyway, so give me an example. Drowning and holding your breath for more than a minute.
Can you be underwater and also like after a minute you can't hold your breath and then start drowning?
All right, we'll work with that. We'll work with that. Okay. How about Mia? Mia, give me an example of 2 things that are mutually exclusive, please. Ah, beautiful. Tomorrow is both Thursday and Tuesday. That's impossible. Both things can't be true. All right. How about Saul? I bet you got something that's mutually exclusive.
Playing a D note on the saxophone, but having it come out as an F sharp.
Oh.
No one gets that. No one gets that.
Playing one note, but a different note comes out.
No, I knew what you meant.
Well, make it easier for them.
Oh, okay. All right, that works. Okay. How about a highly successful lazy person? He might be lazy now, but he wasn't always lazy. Okay. So, any questions on that? All right. So I didn't teach you either of these things yesterday, but I left them for you to figure out because I didn't think they were that hard. And if you didn't figure them out, I hope you got them now. Does everybody have them now? Yeah? Ruby, you got this? Okay. Does anybody have an example of things that are mutually exclusive that they're really proud of? They think it's funny or something?
Okay, even though it's not mutually exclusive?
No, I want mutually exclusive. Nobody's got something that's mutually exclusive that they think's really funny?
Being friends with Isaac and not being mad at him.
Being friends with Isaac and yet not being mad at him. That's awesome. Thank you. Thank you. That's funny, Isaac. All right. Next one, we got a quadrilateral. Let's see. Hey, what are the properties of a quadrilateral? 4 sides. What else? So all the angles add up to 360. We really don't know much else, right? Okay. But it says that the height is 4x minus 2 and the width is x plus 3 and the area is 18. And it says show that this equals 0. So it doesn't really tell you how to do it, but it's actually really easy. You just have to use what you know. So you know it's a quadrilateral, and you know that the way you find the area of a quadrilateral is the height times the width. Not the length times the width, because the length can sometimes be all like pushed over, like a parallelogram or something. So it's the perpendicular height times the width. And so let's set that up. Hopefully this is what you did for part A. 4x minus 2 times x plus 3. What's that equal? 18. So after we do our math, it should equal 2x squared plus 5x minus 12 equals 0. All right. 4x squared, let's see, the outside is 12. Is that my plus 10? Minus 6 is 18. Did I do that right? Yeah? Okay. Subtract 18 from both sides. Is that good? I'm like really, really tired today, and so I'm surprised I haven't made an arithmetic error yet. So you'll have to watch me. Okay. I'm stuck because this not the same. Oh, factor, divide everything by 2. Both sides, right? You have to do both sides. I mean, it's just 0 over here. If you forgot, you'd get lucky. But you can't just divide one side by 0. You have to do the same thing to both. So 2x squared plus 10x minus 12 equals 0.
You have to divide by
The 5, the 10. And there it is. And that's how it's
Mutually exclusive. Mr. Brown teaching a math class and not making a mistake.
Mr. Brown teaching a math class and not going off track.
True right now. That's very true. Yeah. All right. So we're good though? Yeah? Wow, he just dabbed right there. Look at that. Okay. So let's see here. Hey, on a Cambridge test, these are often worth 4 points. This right here, this part. That's easy. That's a lot of points. Especially when, like, to pass the whole thing, you usually need less than 80 total. Literally, for the entire thing, and this is worth 4. That's a huge chunk of what you need.
If you only need 80, how come the last one was like 181?
That was to get an A star.
Oh, to pass. Oh.
Just to pass. So, like, just to pass, 4 points is a huge chunk.
Everyone scores 80 with an A star.
All right. Now, of course, we're shooting for a bunch of A stars this year. A ton of them. All right. Now we have to solve that. First thing you should check is if it's factorable. I heard you guys say it was. So if you didn't get that, I haven't done the factors yet, so I'm going to guess. So don't tell me. But I know that the way you guess is you guess what first 2 multiply to that and what last 2 multiply to that. I know the signs are different because this is negative. So they have to add up to 5, right? Well, if this was a 4 and that was a 3, oh, that would do it. I was just guessing. That does it, right? And I need this to be positive, so like this, because the outside would be -8, the inside, sorry, +8. Outside is +8, inside is -3, that makes 5, so there you go. So x equals 3 over 2, and x equals -4. Do you need both answers?
No.
Yes. Because it said solve. There's 2 answers. You need both. That's usually worth 3 points. Right, I know. You can only use one of them for the contextual problem, but it says solve this. So you need both. That's usually worth 3 points. These problems are worth a ton of points, and I think they're easy. People struggle with them, but I think that it's just lack of experience. Okay, so last thing. Let's see, we have to find the height and the width, so you just have to use this. So 4 times 3 over 2 minus 2, and nope, 3 over 2 plus 3. You have to do both of those, right? Yeah. Okay, so this is 4, is that right? Is that 4? Because that reduces 6 minus 2. And then this one, let's see. Is it 9 over 2? 4.5? Yeah? We're good? Okay. No problems. You sure? Alright. Today, oh, I'm really excited about today because today we're going to mathematically figure out which of your parents is the smart one to ask for money. Not which of them is smarter than the other, but which is the smartest one for you to ask money from. Now, I know some of you don't live with both parents, but, you know. Okay, what it's called, like the math we're going to be doing, it's called expected value. Now, listen, the materials we have for probability are pretty bad. They're low quality. We don't have a lot. Like, there's one more section in the book, and it's the same thing as you did yesterday, which I think is pretty easy. There is, I think, in the hard book and this book, I think there are 3 sections. One of the sections is a review of what this is. There's not a lot of material, so I have to make up stuff.
That's interesting.
All right. So, expected value. So here's the situation. You need money. Why do you need money? I don't know. Let's see. Why do you need money? America, why would you need money?
To conquer the world.
To buy, to fry puppies? Wait. Oh, to buy puppies. Oh. I was going to say.
That's your job, too.
Wow. Wow, Juven went there. Okay.
Oh, Mr. Another example of
Mutual exclusiveness?
Yeah.
What?
Juven going to any class and not insulting his friends.
Juven not insulting people. That's a pretty good one. All right. So you need money because you're going to buy a puppy. What kind of puppy? A what? A lab. Oh, what?
What are you saying?
Oh, a lab. Yeah. Yeah, okay. A lab. Okay. I don't know. So, you're going to ask for money because you're going to buy a dog, right? You know your parents. You know how they act. So you know if you ask your dad, he's going to say one thing first. You ask your mom, she's going to say something first. Like in my house, if I went and asked my mom, she'd probably just say no. If I went and asked my dad, he'd probably just say no. Right. So, but let's say for this example, let's say this is what your dad says when you ask him. Let's say you ask your dad. You're right. Your dad says, all right, you know what? I'll do this. We'll play a little game. We're going to do a coin flip. Yep. And if I toss the coin and I get heads, you get this much money. But if it's tails, you get this much money. Probably not enough for a puppy, but you know. All right. So now here's what your mom says. Mom says, all right, I'll play a little game with you. I don't know which parents would do this. This is just absurd. This is crazier than somebody has 192 watermelons in the back of their car. But let's say she says, we'll play a game. We're going to roll one die. Like, not dice. Dice is 2. We're going to roll 1. We're going to roll 1. And we're going to multiply the outcome. By $3. So, I don't know where my quarter went. So Dad's going to do the quarter. If it landed heads, you get nothing. If it lands tails, you get $20. Mom's going to roll this. Whatever number she rolls, she multiplies by 3. So if she rolled a 4, you get $20. If she rolled a 1, you get $3. Huh? Oh yeah, sorry. What did I say? Hate my life. All right. So $18 if she rolls a 6, $3 if she rolls a 1. So which is the smart choice? That's what we're going to figure out. Now, some people are going to say dad because you get $20 for sure. Some people are going to say mom because you're guaranteed to get something. Some people are going to say mom because it seems like it shouldn't be, and this is a math class, and it always turns out the answer is what it shouldn't be. Right. All right, so here's what you do. This is called expected value. Okay? And this is exactly how, oh man, this is how they figure out, this is how people figure out that the lottery is called idiot tax. Because when you do the expected value for what you spend for a lottery ticket, you can expect to get back less. So you're giving away your money. Anyway. So here's how you figure out expected value. You ready? What you do is you take, and you should write this down because you're going to forget this probably. You take the probability of each event, and you multiply it by the associated value. Do you know what I mean by associated value?
No.
Like the associated value with the head is 0. The associated value with the tail is 20. So like heads 20, tails, oh no, heads 0, tails 20, like rolling a 4 is 12, not 20. I can really multiply, I can, I promise. Alright, you know, so you know what I mean by associated value? Alright. After that, you add up each scenario, like the coin toss, and you add up all of the rolling of the dice, and then you take the average and see which one's more. So you add up like, so in here you're multiplying the probability times like what it's worth. So you're going to take, and you're going to find the average for each experiment. So you're going to find the average for the coin flip. That one's easy, right? And you're going to do the same for the other. Actually, let's say that that's confusing me. Let's just do that. So I was making it more complicated than it is. So you ready to do this? So here's what I mean. We'll do it right here. So for pops, are you ready or no? Yeah? Okay. So for pops, look, you got the probability of tossing the coin and getting a heads, and you multiply that times the value, right? The value is V. So the probability of heads times its value. So probability of heads is 1/2, right? And the value of a heads is 0. So that's 0. Oh, I didn't hear you. I'm sorry. I thought you were asking what I wrote right there. Probability of tossing the coin and getting a tails times its value is 1/2 times 20, and that's 10. Right? So the expected value here would be $10. Good? Okay. What about for mom? How are we going to do that one?
Find an average of that?
No. I was thinking of something else. I got no. Yeah, that's it. Yeah. I'm sorry. So, what about for mom? You have 6 of them, right? You have 6 outcomes. And what's the probability of any of those outcomes? 1/6. So every single one of them has a probability of 1/6, right? So for like the probability of rolling a 1 is 1/6, right? But if you multiply that times its value, then it would be, which is 1/2, right? All right. So you have to do that for all 6, right? But watch, I'm going to set it up easy for you. Would you agree that each of them has a 1/6 probability? Yeah? All right. Do you know what I did right there? Like, do you know where all those numbers came from, what they mean? Say it again, Karima. So those are all the possible outcomes, right? What about that? The value. Okay. So could you just add up all those numbers and multiply times 1/2? Why don't you try it? See what you get. 6, 10. So we good? So I guess the gambler would ask dad and hope for the 20. The smart person would ask mom because you would expect to get more from your mother than you would from your father. Yep. Let's try it. I got it right here. Wonder how much money I got. Wouldn't it be cool if I gave away the money? Oh, that's true. You could ask both. Wouldn't it be cool if I actually gave you the money? That'd be cool. I'm surprised I have $20 in my wallet. Personally. Okay, let's see. Let's go with, I don't know. Let's see. 1, 2, 3, 4, 5, 6. All right, 6. Huh. Mia, do me a favor. Pick a number between 1 and 5. 2. Oh, okay. Mario, pick a number between 1 and 6. 4. That's Matthew. Matthew, who do you want to use, mom or dad? Mom. So you're going to go with the dice. All right, let's see what we get. You got $6. Wait, let's keep track. All right. Let's see here. So we'll pick a number between 1 and 6, please. 3. Okay, 3. And then Alex, pick a number between 1 and 5, please. 1. April.
Oh my gosh.
April, who do you want to try, mom or dad?
I say dad.
Let's try dad. So we're going to do the quarter. How much did you get? 0. All right. Let's see here. Hector, mom or dad? Dad. All right. Heads or tails? Let's see. Oh, you got $20, buddy. All right. Ruby, mom or dad? Mom. $18. All right. Christina, mom or dad? Mom. $6 again. Edgar, mom or dad? All right. Let's see. Ruby, mom or dad? I know. Dad. $20. Did you get $20 last time too? Oh, you got 18. Dang. Whoa. All right. Let's do one more with mom. Oh, 15. Okay, so look, we got 4 trials here. You got $40 total with dad. With mom, what is that?
45?
So here we got 12, 30, 45. Do you see that the expected values are close, and these are actually pretty close also? And you get more money with mom, and that was completely experimental. It might not have worked that way, but if we did thousands and thousands of experiments, it would be very obvious that it would be smarter to ask your mother in this scenario than it would be to ask your dad. All right. So, next up. Oh boy. We got 2 boxes. 2 boxes. Here, I'll just put the picture up there for you. We got 2 boxes, A and B. And the probability of choosing box A is weighted by 1/3. Now we have to figure out what is the probability of choosing a red ball. So I know those colors both look like red, that's why I put this little key right here. I think on your paper too you had one that was kind of like this.
With the bag, and then like going back.
Yeah, with the bags, where you had the probability of choosing one bag was greater than choosing the other. Yeah.
A has 5, right?
So A has
5 red.
1, 2, 3, 4, 5. Yeah. And B has 2 red. This is not expected probability. This is not expected value. This is what's called a conditional probability, kind of. Well, it is, but it's just an example. There's lots of them. Mario, you ready for me to show you how to do it or not yet? He's ready. Alex isn't ready yet. Not yet. Sophia's ready. Yeah? Good. Isaac's ready. Yeah? Isaac, did you make Sophia mad today? Are you feeling okay?
Not yet.
Okay. Whoa. Wow. That's crazy. All right, Matthew. Like if there was no probability of choosing one greater than the other, right? Then there's a total of 1, 2, 3, 4, 5, 6, 7 red, right? And 1, 2, 3, 4, 5, 6. So it'd be 50%. It would be a 1/2 probability, right? But because you're because there's a 1/3 chance you choose this over this, it changes it. Any ideas how we can do this? What do you think?
It should be like 1/3 times box A, whatever it is, and 2/3 times the other one, and add them.
What do you think? What do you guys think about that? Here's what he said. He said, you multiply the probability here of getting a red times 1/3, and you multiply the probability of getting a red out of this one by 2/3, and then you add those two probabilities together. But does that make sense? Why you would do that? I mean, the step is easy, but why would you do that?
Because it's the same reason that the way that it's weighted, so it's like equal.
Yeah, because they're weighted. This one's got a weight of 1/3. That's got a weight of 2/3. And why is this one 2/3 though?
Because that's one.
Because they have to add up to 1, right? The probability has to add up to 1. So there's like two probabilities going on right here. One probability is what's the probability you're going to pick this box, for example. You're not being asked that directly, but you kind of have to fit that in. How did you just hurt yourself sitting in the desk? That was very interesting. Okay. All right, so see if you can figure it out then. Try it. Try it. Did you get it, Sebastian? Yeah?
Are you supposed to like reduce the final answer or no? Just like
It doesn't really matter for probability. Sometimes for probability it makes more sense to not reduce it, but it's like the only time with fractions that I know of. What'd you get?
9 over 10.
All right. What'd you get, Alex? Same thing, huh? Mia, what'd you get? IDK. What's IDK mean? Oh, very good. Man, see, you guys learn. You guys learn. That's excellent.
That's the most
Huh?
important. 2 years.
2 years and you guys have finally got it.
We didn't learn any math, but we learned that.
Yeah, that's true. You didn't learn anything about math, but you learned how to answer the question, what does IDK mean? Yeah. All right. Alexis, what did you get? 5 over 21. Well, isn't that what this one is? But for the whole thing. All right, so listen. Listen very carefully. The question isn't, what's the probability that you pick a red ball out of this box? The question is, what's the probability that you pick a red ball? Total. So you have to do 1/3 times this plus 2/3 times that. Do you see? So it'd be like this is box A right here. And there's 5 red, 7 total. And that gives you 5 out of 21 chance. The other one, 2/3 chance of picking the other box. There's 2 red and 7 total, which gives you 4 out of 21. You add those together and you get 9 out of 21. Yeah? Yeah. The hard part about probability is always setting it up. That's for me. Okay, Christina, you look very happy. No? No. I'm totally confused.
No, I just didn't realize. I
You-
just found box A.
Oh, yeah. So you did what Alexis did. You just did this one. Do you see why you had to do both? Yeah. Hey, Sophia. Sophia, I want to make sure because, here's what makes me nervous. I walked you through this problem, and all you had to do was the math at the end. But when you do it on your own, the thing you're likely to do is just figure out the probability for this box instead of for both. And you have to be really careful. Have to be extremely careful making sure you answer the question. That's the thing that you have to be the most careful of. All right. Now, next example. We got 2 judges. We got Judge Ron and Judge Wright. Okay? And they're going to decide your fate. Yep. There's a 1/4 chance that you're going to get Judge Ron. Okay? Now, Judge Ron's executioner, he's a former sniper. Basically, you're going to be either execution, or you're going to be sentenced to death or not. I don't know what you did. But, I don't know. So anyway, right. And both of them are going to, Yeah. They're both going to kill you. Either one. Whether you get Judge Ron or Judge Wright, you're dead. Okay? So Judge Ron's executioner, he has a kill rate of 9/10. So, like, the probability is what it really should say. The probability that you die with this executioner is 9 out of 10. Okay? I don't know what fantasy land this is, but if you get away, then they let you go. I don't know. Weird. All right. Now, Judge Wright's executioner is Twitchy McTwofingers. He used to play with firecrackers a lot. That's why he's got 2 fingers left. Now, he's not a very efficient executioner. He only kills, like, the probability that he's going to kill you is 1/3. Okay? So, like, this is, of course, just made up. It's all silliness. The numbers are what's important. I didn't have quite, like, this should not say kill rate. This should say probability of a kill. And that's what the other should say too, instead of kill rate. Okay? All right. What crime did you commit, though? I'm really curious. Juven, what'd you do? Dabbing in class. There you go.
He dabs so many times in history.
That's right. All right, he does. Oh, you dab a lot in history, huh?
Oh, I dab every year.
Oh, okay. All right. So anyway, you're going to court and you're going to be found guilty, and the punishment is death.
For dabbing?
For dabbing. I don't know where this is, but this is, fantasy land somewhere. So anyway, you got 2 judges. You got 2 judges. There's a 1/4 chance that you're going to get Judge Ron. If you get Judge Ron, his executioner, you have a 9/10 chance that he's going to kill you. Right? If you get Judge Wright, which his executioner is Twitchy McTwofingers, you have a 1/3 probability of being killed by that guy. So, what's the probability that you're going to be killed? I'll let you guys work on that for a few minutes. It's the same problem as the one we just did, right? Yeah, it's weighted probability. It's conditional probability kind of thing. Twitchy McTwofingers, you like that? You got it already, Mario. You got it already. Easy. Coffee. Has Jesse missed a lot being absent yesterday and today? Hey, when you get your answer, check with somebody. When you get your answer, check with somebody. Check with somebody you don't usually check with. So Mia, when you get your answer, check with somebody you don't usually check with. Who are you going to check with, Mia? Hector. April, why don't you check with Christina?
Everything. 3/12
Ruby, who are you going to check with? Alexis, who'd you check with that you don't usually check with? Oh.
You got 1/4 chance here. You get wrong, so you have 3/4 chance. Oh yeah, I hate all those programs at the highest.
Wait, for who's first in class? For valedictorian you're talking about?
No, it's because like yesterday we were taking a math test, like you could see everyone's names. So
Wow.
it's like, but she is
Current? Yeah, who's second? Sebastian? Who's third?
I think I'm typing it right. There's like 4 people typing it.
So has Kayla she hasn't had straight A's, has she?
She had it. She's the only one that has had straight A's.
Really?
She has the honor expenditure.
Spanish boy.
That would be why right there, yeah. All right, boys and girls. Is that what you got, April? No. Matthew's going to help you. Alexis, you're done now. Who are you going to check with? You got to check with somebody. No, not Hector. Somebody you don't usually check with. Alexis, like you have to go ask somebody you don't usually talk to. No, too close. Go ask America. Where is she? I can't hear you. How many years of? I don't know. Two are required. All right. Have a seat, please. Check this out. All right. Couple things. Jubin. Thank you, Jubin. Thank you. So, Karima, the reason I wanted you guys to ask people that you don't always talk to is because you get so comfortable with certain people that No. But like I think it's important to most of the time work with people you're comfortable with working with. However, sometimes that means you only learn a certain amount, and when you go out of your comfort zone, not all the time, just a little bit, then you end up learning more when you end up talking to people you don't normally talk to. So that's why I asked you to do that. I think it's really important. Second thing is, and I'm guilty of this just like everybody else is guilty of this, a lot of times when we're taking notes on math, we're so particular about the numbers that we don't write down what the numbers mean. And so I was very, bless you, I was very careful when I did this problem that I wrote down what those numbers mean. Look, so these are the two judges, Ron and Wright. You see it's kind of like wrong and right? You see that? Anyway. So I put these, I described what the numbers meant. So it's not just a bunch of numbers being multiplied. The hard part's not the multiplication. The hardest part is writing those numbers. So the 3/4 right here, I think, caused some trouble for some people. They did, like I heard. Yeah, I wasn't just sitting here, I was like watching and listening. I heard people talking about middle names and other people talking about their team losing by 22 points and some other people just working the whole time. Right. Anyway, Hector. Can you tell me, Hector, why this is 3/4?
Because that's the chance of you getting that judge.
Yeah, and how do you know you got a 3/4 chance of getting this guy or this lady?
Because it said that you have 1/4 to getting the other judge.
Right. So 1/4 and 3/4 is 1. Yeah. All right. So April, do you see why that is? Yeah? Okay. Fantastic. All right. Last one.
Now we're super sad. Why you do this?